Ladies and gentlemen, Professor Voeikov.
Thank you. Thank you very much. First, I would like to many thanks to Rachel and Alex, who invited, and all the organizers of this most impressive and informative meeting. I'm here for the first time, but I'm already impressed, and I think that I will be overloaded with information by the last day. Well, and also I would like to say a few words about the authors of this presentation. Professor Alexander Konovalov, whose data is the core of this presentation. He is the member of the Russian Academy of Sciences. Unfortunately, he couldn't attend these meetings. He is 84 years old, and his health, fortunately not mental health, is a little deteriorating. So we, together with him, are not homeopaths at all. Professor Konovalov is one of the leaders of supramolecular chemistry in Russia. So he is a physical chemist. And I am not a physicist, but I am a biophysicist, and biophysicist with the emphasis on bio. So I'm graduate from the Faculty of Biology. So I know physics as a biologist, but I mostly feel myself as a biologist, the person who understands that living things somehow should be very different from dead things. So why we are together? Because about a couple of decades ago, I understood that we biologists, biophysicists, molecular biologists, and biochemists, we study all this organic stuff which is in the living things, and forget, as I understood half a century after St. Yerdy, forget that the major stuff in all living things is water. In fact, one can say that we are a little dirty water, though without this dirt, we are not alive. And we study water in the biology very, very slowly, and in fact don't understand its properties. Konovalov, he was an organic chemist and physical chemist. And before 2000, he practically also didn't pay attention to water. And why he began to study the properties of aqueous systems, I'll tell in this lecture. And why also we, together with him, got interest in the problems of not only homeopathy, but of so-called ultra-high dilutions in general. So when we came to this field, we, of course, knew and we understood already that homeopathy is a very bad word for chemists, physicists, and especially biologists. Because my students and postgraduate students, for whom the Wikipedia is a holy source of information, they look at the term homeopathy, and what they see, that it is a pseudoscience, a belief that it is incorrectly presented as scientific, and it is not a plausible system of treatment, as it dogmas about how drugs, illnesses, human body, liquids operate are contradicted by a wide range of discoveries across biology, psychology, also physics and chemistry made in 2 centuries since this invention. And when people read this in such authoritative source, of course, they lose any interest in homeopathy. Why these people claim that homeopathy is pseudoscience and it contradicts all the evidence in physics and chemistry of not only life, but also in non-living systems. I will not go into details. You know it much better than me how to prepare these ultra-high homeopathic dilutions, homeopathic remedies. The major point is that ultra-high dilutions, which are not always homeopathic remedies, but in some cases they are really ultra high, may be practically devoid of molecules of the original material. And according to dogmas of biology, homeopathy challenges one of the major dogmas, major postulate of contemporary biology, that all biological processes are based on specific local interactions of biomolecules, which are particles, that are adjusted to each other as key to the lock. You can look at many different examples of this key and lock action. One of the most obvious is any ligand. It may be neurotransmitter, it may be hormone, it may be substrate of an enzyme, which feeds to the receptor, to macromolecular, as a key to the lock. And when they meet each other, when they make this unity, then there is a biological effect which is triggered. And when you don't have this ligand, of course, how can any biological action be resulted? In fact, the interaction of molecules with each other in biological system cannot be denied at all, and it is observed by many different methods. And this hypothesis, in fact, this is hypothesis, and Paul Ehrlich, who launched it more than 100 years ago, he said that it is a hypothesis, not the final truth. But it is supported by some empirical data and many facts concerning biological regulation, but however, are not explained by this hypothesis. And a wide range of empirical evidence across biology, physics, and chemistry made during the last century suggests that there may be alternative mechanisms of interactions in biology. And in brilliant several lectures this morning, all this, the evidence was presented, and it was told that there are hundreds probably of papers which cannot be explained, where the interactions, where the biological effect cannot be explained by this simple key and lock process. So now we have this contradiction, which is written in very bold sentences in Wikipedia, and a lot of evidence. And so in order to resolve this contradiction, the first question to answer before any discussion of the clinical efficacy of homeopathy, I mean only discussions, not the usage of homeopathic drugs, it's different things, is to answer these questions. Do serially prepared high dilutions of mother tincture differ first in their activity, and second in their physical chemical properties from pure solvent, for example, water, when a concentration of an active substance in them becomes negligible? Just here, for example, this 12 centennial dilution, is it different from the solvent with which this dilution was prepared? Is it different in its activity or in its physical chemical properties? If we don't see any of this difference, then homeopathy is illusion. If there is such a difference, then homeopathy has a scientific foundation. It doesn't mean that we answered the question how it works, but at least it is not a pseudo science already. Well, just a few words. From our point of view, homeopathy is not science at all. You see, homeopathy is a practice. It is a medical practice. Science is a completely different thing. That's our personal point of view. But any practice may have a scientific foundation already today, or may not yet have the scientific foundation, but still you do not deny that this practice exists and it does some things. So when I use the word homeopathy, I mean something which underlies it, this scientific foundation. Okay, today there is already some reports, in some lectures, it was told that there are a lot of evidence that homeopathic remedies or preparations of ultra highly diluted preparations can exert some biological effects. And I would like to remind you that first papers proving that ultra-high dilutions in degrees exceeding the so-called Avogadro, the ideal figure, which is Avogadro number, reaching in some cases 10 power minus 4,000. And such dilutions were prepared, of course, by Germans in the second part of the 20th century, because I don't think that Russian could go so deep. Possess biological activity, and the first papers appeared more than 100 years ago already. And by today, several analytical reviews, which were just already discussed here, show that there are in vitro effects of homeopathic remedies. I would like only to add to these brilliant lectures which were here a few evidence which was obtained in Russia, as a matter of fact. By the way, homeopaths know very well the name of Korsakov. There is Korsakov dilution, who was, of course, a Russian. The founder of the structural chemistry, Butlerov, in 1880s, also was a supporter and fighter for homeopathy. He is considered to be one of the real founders of structural chemistry in general. There were the founder of Russian pharmacology, Kravkov, published in 1923 a very big paper showing the biological effects of very high dilutions. And large-scale studies of biological effects of ultra-high dilutions were started in USSR in 1980s by Professor Burlakova in the Russian Academy of Sciences. And her first published paper appeared 2 years before the paper of Benveniste, where they demonstrated the antioxidant effect at 10 to the minus 15. And over several decades, there was intensive research by Burlakova and other people, associates, who has shown that dozens of natural and synthetic biologically active substances can influence different biological test systems. I will, from of these dozens of different compounds, I would like to dwell on one compound, which is synthetic compound, which was synthesized in their laboratory, so-called potassium phenazane. We'll talk a lot about it, but just it's one of the examples with many properties similar to other biologically active substances. Well, this potassium phenazane, it turned out that this compound in ultra-high dilution has a very wide spectrum of different biological actions. And for example, it may, when you look at the dose-response curve of the protein kinase C, which it activates, you can see usually two, if you don't go below this Avogadro number, two peaks. And one of these peaks is under so-called normal concentration of potassium phenazane, something like 10 to the minus micromolar, but another is 10 to the minus 18 molar. And so what is it, 10 to the minus 18? It means that if just to calculate, it is one molecule of this low molecular weight compound can activate 10 to the power 9 molecules of enzyme, which is, of course, some crazy situation. So by key and lock explanation here already doesn't work. A lot of results were obtained with this potassium phenazane, and as a matter of fact, it in ultra-low concentration, it is now even in Russian pharmacopoeia. And Alexander Ivanovich Konovalov, he also he wasn't thinking about ultra-low dilutions until one of his synthetic compounds, he synthesized it, began to exert biological activity at dilutions 10 to the minus 9, higher 10 to the minus 15 molar, and so on. And after this, he got into contact with Burlakova, and he understood that at this ultra-low concentration, there are practically no molecules which could exert their biological action. And he just stated that we share the general accepted point of view that the number of molecules of an active substance in ultra highly diluted solution is too small for inducing biological effects. So for the first time, he asked such a question, very straightforward. So maybe highly diluted solutions are not solutions at all, he said. It's something else. And in order to understand if these highly diluted solutions are not solutions, are not just water, he decided, being a member of the academy, he managed to find some funding in order to perform a very comprehensive, very big work with a rather small group. So he began to study these ultra-high dilutions with the conventional today methods of studying aqueous systems. One of the methods was dynamic light scattering, which this identifies the presence of particles from nano-sized particles to micron-sized particles in water or other solvents. And this method also measures their dimensions of these particles from 0.6 nanometers to 6 microns. Another contemporary method is nanoparticle tracing analysis, which can tell you about the concentration of particles if they are present in this water. And other very well-known methods, precision conductometry, that is measuring electrical conductivity of solutions, pH, surface tension, etc., etc. And when he applied these methods to study the properties of solutions of different substances, starting from normal concentrations, 1 millimolar, for example, and going down to 10 to the minus 20, he has demonstrated, at least for the first time in a serial dilutions, that when you dilute this very well soluble in water compound whose diameter is 2 nanometers, then he could see that, for example, all the solutions, so-called solutions now, they contain particles whose diameter may be as big as 450 nanometers. This is half of a micron, or half of E. coli microbe. So, and at this concentration here, 10 to the minus 18, of course, there are practically no molecules of phenazane there, if they are there, but their quantity is so small that it is not significant. So you can see that when you go further and further with dilutions, there is again the concentration effect, so to say, curve is not smooth at all. It has the peaks and valleys. Okay, then it turned out also that nanoassociates, which he found in this solution, they are not some neutral particles. They have electrical charge. And that is most interesting, that if you are looking, the charge of particles will return back to the particles which are can be observed at normal concentrations. They shouldn't also be present here. But these particles at normal concentration are charged positively. And when you go below 10 to the minus 6, with again this phenazane, potassium phenazane, then these particles are charged negatively. They have a negative zeta potential, so to say. So they are not neutral particles, they carry charge. There are also other properties which are, I would say, the holistic properties of the whole system, which are so different from the properties of a solvent. So ultra-high dilutions containing nanoassociates, they exhibit non-classical behavior as holistic system in general. Their surface tension is not surface tension of water. Here is surface tension of water, and here about 10 to the minus 16 molar. Surface tension is significantly lower than the surface tension of water, and surface tension is the characteristic of solution in general. Electrical conductivity of ultra-high dilutions are much higher than electrical conductivity of pure water, which is used as a solvent. This is also cannot be explained very easily because according to usual physical chemistry, electrical conductivity of water is related to ions which are present in water. But you take very pure water with such conductivity, you make further and further dilutions, and its conductivity increases. So it's again not usual conductivity, something else. In fact, he studied, I gave you just as an example, potassium phenazane, but they studied more than 100 different compounds, from low molecular weight compounds. Here are just, they belong to completely different groups of biological active substances, of chemical substances, and so on. And it turned out a very important result, that not all substances were giving these nano-associates in ultra-high dilutions, but only about 75% of them. 25% of substances which they tested didn't give all these nano-associates. They didn't have any problems with the electrical conductivity, with pH changes, and so on. So that already is an internal control, so to say, which shows that what they observe, it's not the result of procedures. It depends upon the original substance which is used for further dilutions. And there is now the good answer why some substances produce nanoassociates and others do not produce nanoassociates. But for example, if to compare two very similar substances, benzoic acid and salicylic acid, which is different from benzoic acid, then benzoic acid's ultra-high dilutions are just pure water in all their properties. And the ultra-high dilutions of salicylic acid have all these paradoxical properties of ultra-high dilutions. So they studied also a lot of other different substances. Now there is the idea that it has to do something with hydrophilic ratio, and also the electronic architecture of these molecules, if they can produce or cannot produce all these nano-associates. At one of the first slides with this potassium phenazane, I have shown that these big nanoparticles appear also in non-diluted solutions, in solutions with normal concentration of this particle. And it was not discovered of Konovalov. It was discovered at the beginning of this century that when you have solution, then in this solution, you can find that it doesn't behave as solution. It behaves not only ultra-high dilutions behave illegally. That's violating the law of behavior prescribed in the textbooks of physical chemistry. Also, normal aqueous solutions of virtually all known substances, from low molecular to high molecular, for example, alcohol in water doesn't behave as it should be expected, that alcohol molecules should be evenly distributed in aqueous systems. No, they are not evenly distributed. And here I again return back to potassium phenazane and show you that when you have concentration millimolar, there are particles there, nanoparticles there. You dilute this solution 10 times, and the size of nanoparticle not decreases. They do not disappear. It increases. You dilute it 10,000 times. It again increases. It is less of the substance in the solution, but it becomes more and more non-even, non-homogeneous solution. So the diameter of these nanoparticles, which are called in chemical literature now domains or supramolecular complexes, in the range of normal concentrations, increases with dilution. And here is that means already today, the textbook concepts which we continue to teach our students about the properties of usual aqueous solutions need serious revision. That already the science of solutions which we know from the 19th century, it is, at least non-full science, or probably wrong. Science. So we need to pay other attention, to pay new research in the solution in general. And here is another question. Is there a boundary between the normal solutions containing domains and ultra-highly diluted systems where nano-associates are present? So there are normal solutions, down to 10 to the minus 6 micromolar, so to say, and there are 10 to the minus 18, 10 to the minus 24, and so on, ultra-high dilutions. Do they have any boundary between them? And what was discovered? It was discovered that for the emergence of nano-associates and all other paradoxical properties of ultra-high dilutions, which are just some, in a sense, homeopathic remedies, it is necessary that they are affected by environmental electromagnetic fields. If you prepare this dilution, very high dilution, and put it into a vial, and put this vial in the container, which shields practically completely from the environmental electromagnetic fields and also earth magnetic fields, then the preparation which was not shielded and preparation which was shielded by the, for example, this permalloy, so to say, screen, where electromagnetic fields are attenuated by 2000, the behavior of ultra-high dilution becomes very different. So what was shown? That if you take these two series of potassium phenazane and dilute this potassium phenazane down to 10 to the minus 7, there are domains here. If they were independent, if they were shielded or not shielded from the environmental electromagnetic fields. But if they were shielded from environmental electromagnetic fields, then no nano-associate appear in further dilution. If they were not shielded, here is this normal curve. So when you shield the preparation from environmental electromagnetic fields, then not only nano-associates disappear, but also fluctuations of electrical conductivity, of pH, and of surface tension. That's all these paradoxical properties of the solution disappear. This solution is already not a solution, but just a pure solvent. And also the biological activities of ultra-high dilutions also disappear if this series dilutions are kept shielded from the magnetic fields. Okay, from this it follows not only from this only paper works, series of works, but from other series of works it follows that seriously agitated ultra-high dilutions of the mother tincture differ in their physical-chemical properties from a pure solvent, even if the concentration of substance in them becomes negligible. So this very, very high dilution is not equivalent to the solvent, only if two conditions are fulfilled. First condition, if they are under the action of environmental electromagnetic field, and second condition, if the original mother tincture contains compounds which have biological activities. If they are just inert compounds, then the 12C and water are the same. Okay, so the mechanistic key and lock concept suggested in the 19th century cannot, of course, explain how can ultra-high diffusion dilutions manifest biological and other forms of activity. And of course, after this, the question, of course, arises, what mechanism of actions of ultra-high dilutions arising from their complex dynamic nature may be proposed? I'm not the only and not the first to show that the key and lock concept of the 21st century can explain this interaction. And we use this key and lock concept every day in our everyday life. And don't think that, in fact, when we need to go to the metro, for example, you don't need to find a key in your pocket and put a key hole and put your key into a keyhole in order to open doors and get outside. You may simply have something which affects the magnetic receptor of your lock, and the lock will open. And here is also the lock of the car is open when you use this modern key and lock concept. And accurate and much more selective action at a distance due to resonant interactions may emerge if the partners participating in them are far from equilibrium and represent oscillating entities. I have a very small piece to continue, but I now lacking time, and I would like only to say a few words that when we are dealing, so what it means that the partners participating in this interaction, key and lock interaction, unlike 19th century key and lock, are both active. I'm not sure that we can revive a dead mice using homeopathic remedies already. It should be alive. It means that it should be active. It should be excited. It should be oscillating. And also the homeopathic remedy, it is not just the complex mixture of nanoparticles and solvent in which these nanoparticles are embedding. These remedies are also active. And these are already the 5 sense of my group into this problem, because we have shown that practically all water which we have here in glasses or everywhere in the body, this water is an active substance, active chemically. There is burning in this water. That means that water is oxidized by oxygen, which is present in water. So it is under especially under potentiation, under the presence of different compounds. Yes, I have 7 minutes, but I just finished. So in fact, I'll just finish, you see. So I mix here, and this energy which is in this burning water doesn't dissipate into heat. It may be used for excitation of nano-associates present in ultra-high dilution and in reactive oxygen species. So aqueous system present in the excited state represent dissipative systems. So they are oscillatory in nature, and these systems turn into the source of oscillatory electromagnetic fields, and they work like this modern key, and the receptor works like a modern lock. So this ultra-high dilution may serve as emitters and receivers of oscillatory signals in extremely wide frequency range. And the last slide. I started from the claim that we, together with Professor Konovalov, are not homeopaths at all. And the only thing on which we insist, that problem of clinical efficiency of homeopathic drugs should be decided by medical doctors. I will not go to Konovalov, and Konovalov will not go to me to ask which remedy to use in this and that case. We'll go to many highly qualified medical doctors who are in this auditorium in order to ask what can help us. But these medical doctors should not pay attention now to the paper in Wikipedia, because homeopathy doesn't contradict modern physics and chemistry. It has a very solid scientific foundation. So thank you very much.